Welcome back. In this video, we'll be looking at two protocols that help network administrators keep their systems running. The first is ICMP, Internet Control Message Protocol. Hosts and routers use ICMP for queries and basic error reporting. ICMP operates at the network layer. The ICMP message is encapsulated in an IP packet as the IP payload, much like OSPF. It is identified by its upper layer protocol number 1 in the IP header. The specific function of the ICMP message is identified by a type and a code. There are two types of ICMP query messages: a request sent by a host or router, and a reply responding to that request. The most common request reply is the echo request reply. You are probably familiar with this as the ping command. As an aside, the developer of ping chose that word because ping works analogous to the sound that sonar makes. Later, someone created a phrase so that ping would be an acronym: Packet Internet Groper. ICMP can also be used for router advertisements and router discovery. ICMP error messages report problems. They are typically sent when a packet is discarded. These error messages are often forwarded to the application. This next slide shows the list of ICMP error codes. You probably have seen some of these errors, particularly when you have pinged a host that is shut down or unreachable. Traceroute is a network diagnostic tool that uses ICMP. Traceroute displays the route taken by packets across the network between two systems and measures any transit delays. Traceroute makes use of a field in the IP packet header called Time to Live, or TTL. We briefly talked about this last week. Recall that TTL is not measured by the number of seconds, but the number of hops. It is the maximum number of hops that a packet can travel across the internet before it is discarded. There are various implementations of the Traceroute program using UDP, ICMP, or even TCP. The Linux Unix version of Traceroute uses UDP. The way that works is depicted on this slide. Traceroute sends a sequence of packets from the source to a destination host using the UDP protocol with an unlikely source port number. The first packet has a TTL of 1. The second packet has a TTL of 2, and so on. Each time a packet is passed to a new router, the TTL is decreased by 1. When it reaches 0, the packet is discarded, and the router returns an error message, type 11, code 0. This means the TTL time is exceeded. Along with this information is information about the router name and IP address. By sending packets in this manner, Traceroute ensures that each router in the path will discard a packet and send a response. When the source receives the router response, the source records the round-trip transit time. When Traceroute reaches the destination host, the behavior changes. This time, the host returns the ICMP message, destination port unreachable, which is type 3, code 3. Note that the Windows command is TRACERT, and it typically uses ICMP instead of UDP, unless a special command switch is used. This slide shows the Traceroute from a Windows PC. Each router hop is shown with 3 different transit times, and the hop's IP address plus the hop's DNS name if it can be resolved. There are 3 transit times because 3 packets are sent each time for each hop by default. We talked about 2 different approaches to the control plane. We studied 2 traditional routing algorithms, link state and distance vector. We have looked at 2 internet routing protocols, OSPF and BGP. We also discuss how routers running these protocols are aggregated into regions for scalability. We delve further into software-defined networking. And finally, we briefly examine two protocols, ICMP and SNMP, that are used for network diagnostic and management. Next week, we will dive into Layer 2, the data link layer.